working on it with our Engage app, which is contact center software. So linking our customers up with our agents over WebRTC. So what we have to talk about today is multi-point video conferencing with WebRTC and SFU. So if you would like to talk about more about some of the basic stuff, I'd be glad to do that. Just speak up, let me know. There's not a ton of people here. So I want to talk about what's useful to you all, but also give you a rough idea of this while we're at it. This is Dave.
Hi, I'm Dave Ertl. I work on the infrastructure and core team, building out the video infrastructure behind WebRTC for our selective forwarding unit, which is a Jitsi video bridge. We'll talk a little bit about that in a little bit more.
So to give you an overview of some of the terms we might use today, it's a big jumble of terms, but they all make sense. And if you want to look at these slides later, they are available online. Sorry if it's a little hard to read. Signaling is what you call the transmission that happens between clients to establish a connection. So if you're familiar with traditional telephony at all, you know about SIP. SIP is signaling. So we also have XMPP is signaling. Hey,
Hi.
how you doing?
Good.
Good
Sorry
seeing
I'm
you.
late.
No problem. Grab a sandwich and enjoy. So SIP is a signaling protocol. XMPP is also can be used as a protocol for WebRTC. So when you're doing WebRTC signaling in XMPP, there are two XEPs. XEPs are XMPP extension protocols. So the two that are relevant are Jingle and Colibri. Jingle is the protocol used to negotiate sessions, to initiate and negotiate sessions between clients. And Colibri is the protocol used for coordinating an SFU for multi-user chat with video. So WebRTC, as you probably know, stands for Web Real-Time Communication. I won't really talk about ORTC today. I'm just going to talk about that at the next meetup if people are interested. ORTC stands for Object Real-Time Communication. It's an alternate set of APIs that will probably converge with WebRTC in the next version. ORTC is what Microsoft Edge supports right now, as opposed to WebRTC. ICE, Interactive Connectivity Establishment, is used for discovering IP addresses and ports used to establish UDP and TCP streams. ICE is comprised of stun and turn. Stun is session traversal using NATs, and turn is traversal using relay around NATs. So DTLS and SRTP, if you're familiar with media lines.
For remembering those acronyms.
Thank you. I think it's probably it took me like 12 times to get them right, but yeah. So stun and turn are really the how do I actually discover the location of my peers on the network. So talked about some at the first meetup, but if you are interested in knowing a little bit more about how that works, definitely let me know. DTLS and SRTP are how the data streams themselves. So DTLS for data channels, so for transmitting data between peers, and then SRTP for secure transmission of real-time media. So that's underneath UDP and TCP streams. So on computer, to give you an overview of what the architectures look like, I'll start with this one. This is called a mesh network. This is what we have now. In our application, we're working to add the SFU. So I'm looking around for a whiteboard marker, but I don't see one. You see one?
Yep.
Cool. Okay. So the mesh network is where all your clients are connected to each other. This is really a peer-to-peer. And it's great. It works because peers can usually pretty easily connect to each other. It becomes a little more complicated when you do have to do traversal or using relays around that, but it works pretty well. The main problem with this is that it doesn't scale. So when you have, as you can see, when you have 5 clients, there's a lot of parallel connections going on here all at once, and it's really a fragile system. So if one person drops, it's going to really affect everybody. Not even that they're going to lose the stream, but that means they have to renegotiate streams. So while you're trying to encode your media and upstream it and download media and display it, you're also trying to renegotiate streams for that one person who had a blip in their internet. So it's really unstable.
So what about doing it like the old-fashioned way with like telepresence units with the rendezvous point?
Yeah, exactly. So that's what we're going towards. That's the SFU. So in this topology, you've really got this one point, this selective forwarding unit is what SFU stands for. And that's where it gets media from each of the clients and it relays them to each one over the single connection that they have. And we'll talk about some of the benefits of that. But just to go back to this real quick, I want to show how, so one of the problems we've seen is what people are calling parallel universes. And parallel universes happen when something like this occurs and the marker doesn't work. But it's okay. I think everybody can kind of get the gist of it. When a connection breaks between, a few of the clients, you end up getting these two clients connected and these three clients connected, but they're all in the same conference. So they kind of have this, they feel like they're in parallel universes. Thank you. So the line going here, you can imagine that all of the connections that line crosses are suddenly broken. It really just makes it a fragile system overall. And they're all trying to renegotiate those connections all at once. And it's just a big problem. It doesn't scale. And it gets even worse if you try to add more than 5. What we have seen is that 5 is really the upper limit. And that's even on good networks with good hardware. So the selective forwarding unit is where we're going with that. So let's see. So Dave, do you want to talk about the AWS architecture?
Sure.
This one? Okay. Does anybody have any questions so far?
So the selective forwarding unit that we use is from Jitsi. It's called the Jitsi Video Bridge. Jitsi was recently acquired by Atlassian. It's an open source project, and Atlassian has vowed to keep it open. We'll see how long that lasts. Hopefully it keeps going. But the way we deploy ours so ours are deployed on EC2 instances in AWS. We use an ELB, but only for health checks. So in order to talk to a selective forwarding unit, you need to have an XMPP server that acts as a focus controller.
Sounds like Jabber.
Yeah.
Yes.
Yes.
And so XMPP is so we use that for a couple of reasons. One is it's our chat service. We have chat in our application and we power that exactly, and it's a standard. And we want to be interoperable with other applications that use it.
Microsoft moving away from Jabber. You've got Google moving away from Jabber.
I have heard that the people responsible for moving Jabber from Google has been fired.
Oh, really? Okay. They're moving back towards Jabber.
I would like to see that happen, and I know that it'll be difficult, but there are some good people in leadership now.
Okay.
Yeah, so we have an XMPP server. It's called our real-time server. We have a cluster of those machines. They act as a focus controller. So basically, our clients speak XMPP and Jingle to real-time cluster, and then the real-time cluster speaks to the video bridge using Calibri.
This is all virtually sitting just in the server somewhere?
These are deployed in EC2. So all of this is in the cloud in Amazon Web Services.
Wow.
Yeah, so it's pretty cool. So the clients never talk directly to the video bridge for the signaling. So real time is only useful, or it's only used to set up the initial signaling. So a client, when it's in a room using XMPP, it sends a presence message that says, hey, I've turned on video in this room, or audio. So some type of media stream in this room. So our XMPP server gets that message, and it kicks off a conference on the video bridge. It sends a Calibri message to the video bridge, sets up a conference, and it allocates channels, media channels for those clients. Once that happens, the video bridge returns a message to real-time, and real-time takes that and forwards it on to the clients with a session initiate. So when that session initiate hits the client, then the client try to connect directly to the video bridge to establish their media streams. And the XMPP server kind of steps out of the way. So once these have a direct connection, their media streams go directly to the video bridge, and the video bridge forwards them on to the other clients in the network or in the conference. So basically what you end up with, like in that mesh topology, if you have 5 clients in there, you are uploading your stream 4 times and you are downloading 4 streams. With a selective forwarding unit, what you do is you upload your stream one time and you download 4 streams. So those 4 streams will come from the video bridge. So the video bridge takes your upload stream and it forwards it on to every other client in that room. So it saves you a lot of upload bandwidth.
The video bridge is an endpoint as far as the client is concerned.
Yeah, the video bridge is exactly an endpoint. It becomes a peer on the network.
Yeah, basically, yeah. I kind of like to say all peers are equal, but some are more equal than others. It's a more equal peer. It connects to everyone, whereas everyone connects to it.
And just some ancillary stuff, like the video bridge provides a capability to publish statistics. You can subscribe through XMPP PubSub, and it will publish it as often as you want. And the statistics will give you like number of conferences you're running, how many participants are in those conferences, how many video streams you're running, and what your bit rate is. So we publish that stuff up to CloudWatch and New Relic, so we can use that stuff for scaling, so that we can tell when a bridge is getting to its limit of the number of conferences that it can handle. Through CloudWatch, we can scale up another bridge and add it to the cluster.
I'm guessing you simulate this here though without having to go to Amazon.
No, we deploy everything into Amazon.
Yeah.
So for our dev environment, tests, staging, and
So I was
production.
wondering about scaling the number of video bridges you need, the number of users. Do you have like a rough rule of thumb? Considering how many users can be on?
Jitsi has some metrics out that they've published for tests they've done. Unfortunately, most of the testing that has been done has been on hardware, directly on boxes,
Yeah, of course.
as opposed to being virtualized up in Amazon or a similar service. So I think we're kind of pioneering this. So we have yet to be able to give any confident numbers. I think.
Yeah.
Cisco, for example, would have rack on rack
Exactly.
on
Yeah.
rack of these video bridges.
Yeah, and we're always going to be IO bound. I mean, when we were running 10 people on an HD conference, the CPU and memory aren't even touched. They barely even register on the box because it's just forwarding media. It's not doing anything to transcode or deep packet inspection or any of that stuff. So there's no transcoding within the bridge. It's a selective forwarding unit, so it just forwards media. It doesn't do any transcoding. So that's another thing to mention is during the initiation process, or when the negotiation happens between the clients, you can control what the bridge accepts, right? So our focus controller only sends out a certain set of video protocols and audio protocols. So we support Opus and VP8. So that's all we send in our SDP response. So that's all the client has to go on. So you can kind of control which codecs you want to use. Let's see what else. And so any questions on this?
How do people interwork? Somebody else writes other pieces of software they may not be using the same signaling protocol.
So we support Jingle for our signaling protocol. So it's an open standard. The only thing that we have that's special is a special presence message that initially comes into the conference to say, I've turned on video and audio. There's no standard for that one yet. We're trying to work on establishing a standard for that with Anyet as well. But there is no standard for how do I indicate that I would like to up my presence from regular chat to a media presence.
It was really the way that it would be is not a good one. What's defined in the standard, and it's highly debated. It would be basically a step to have a more clean way of doing it.
But you're running a service, somebody subscribes to it. There's another company somewhere else.
Mm-hmm.
No, I don't think so.
Yeah. I mean, so if you're talking about another company, say integrating with our service, right? Is that what you're asking?
Yeah.
Yeah. So that's possible, right?
But they would have to be using a similar signal.
Yeah,
They would have to be
that's
using
what I was-
XMPP.
I was trying to
Yeah,
figure
and
out.
I think that's the main difficulty, and that's the reason they tried to make it XMPP. Do it as the broadest standard we can.
Mhm.
But Google right now, since they had moved off of the others using the different signaling for Hangouts, it wouldn't integrate. You have to be the same on some level, and that's the level to negotiate calls that we would require them to be the same on.
Yeah.
But for example, Talkie.io uses XMPP and Jingle, as they're signaling. So if we set up user federation, we
For
could
instance, Talkbox,
talkbox.
yeah, so they sell a service.
Mhm.
And some company implements it. Somebody else is using that service if you want to talk to them.
Mhm.
What do you do?
For XMPP, you would use federation. So you would say, I'm going to route my messages for these JITs to this other service.
Any more questions on this? So the benefits of having an SFU is increased stability because you don't have so many streams that you're renegotiating all the time. You have a single point. Reduce CPU and bandwidth for the web and mobile clients because you don't have as many streams that you're having to upload all the time. So some of the other things that the bridge does that's really nice. So we talked about being IO bound, right? You're always going to be network bound with this kind of stuff. So if you have 10 people in a conference, Jitsi provides a capability called last in. So it will take the last in dominant speakers and it will only forward those streams. So you could have last in set at 1 and it would only take the person that is speaking. And that video stream would be forwarded on. You don't lose the connection, it just pauses the media stream. So that saves you a lot of bandwidth as well. That's something we're working on turning on for the Jitsi video bridge as well. Another thing that it provides is simulcast support. So simulcast allows you to upload 4 different quality or in different quality streams at the same time. So you can take your video, you can have an HD, medium, small, and then low resolution stream. And then the bridge will support that so that you can selectively choose which stream you want. So if somebody is thumbnailed, if they're not the dominant speaker, you can provide the low bandwidth stream. So an additional optimization. Another thing we've been looking at is video survivability. So what happens if you lose a bridge in the middle of a conference? What do you do about that? We're looking at ways to use the bridge. We store all of our bridge state of conferences, who's in what conference, and what messages they have published. We store that in Redis so that if we lose a bridge, another bridge can come online and pick up where that one left off and basically reestablish all the streams. Maybe we pop up a spinner on the client to say, hang on, we're experiencing network problems.
What have you noticed in terms of losing a bridge using Amazon? Have you ever lost a bridge?
No.
We're not so far in our development process that we've hit that. I mean, to be very open with it, this isn't in production yet.
Yeah, this is a development
Yeah,
effort.
we've been in development with it. So when in the development one, we tend to just, we haven't, the bridge hasn't gone down.
No. So the bridge is a simple Java process and it runs on EC2. It's very reliable. I mean, I've been working here for 2.5 years and I don't think I've ever lost an instance in all the other services I've written in EC2. It's just, you don't lose instances because we cycle through them very quickly. They don't run for very long. They run for a couple weeks at most. We push new code. We throw our instances away. So I wouldn't expect that to happen. It's going to be a very low probability that that's going to happen, but we want to be able to handle it gracefully too. So by storing all the conference state in Redis, when a bridge goes away, we can have another one immediately come up and start to repair that conference. It will remain to be seen how quickly we can do that and how reliably we can do that. Right? That's the idea, though. So some of the other benefits that the bridge provides, there's a large open source community around this. A lot of people have written plugins for it. There's a screen recording, video, audio recording plugin. It basically joins the conference as a dummy client. And so all the streams get forwarded to it and it writes them out to disk for you. So you could write them out to disk. You could push them up to S3, Dropbox, anywhere you want to push them. There's also a plugin for SIP trunking so that you could do a dial-in number using your SIP client and it would connect it to an in-progress conference and allow you to get the audio streams. So that would also be very helpful. The bridge itself acts as an ICE server. You don't need a secondary ICE server for it. And then this is some stuff that we have a proprietary SIP service within our organization.
But another thing you kind of put in place with that last item is, say you wanted to use Watson APIs
Sure.
and you wanted to do some analytics on the audio, you could definitely do that too.
Yeah.
You could have it connect as a plugin. It could stream the audio as blobs, FWATs, and that could grab them, process them, and give you some data back.
Yeah, using the same technique just to connect as an XMPP client, and then you have all the streams at your disposal to do whatever you want with them.
So who assembles the stream and display?
So we do that on the client side.
On the
So
client
so
side.
how that works on the client is if we go back over to this slide right here, each one of these streams is a WebRTC peer connection. But on each arrow, what you would actually see is one stream up, and you would see 4 streams down. And so we're kind of balancing the load of who has to do so much. So there is the idea of an MCU, which is the strategy that Google uses, where it actually multiplexes the streams on the server side and sends them down as a single stream. We don't do that because it's very expensive to do that. So by streaming down the multiple streams, it also gives us the flexibility to do various things on the UI. We can reorganize them, we can hide them, we can change the size and presentation and all of that.
The actual video stream,
The rendering?
is that itself in layers?
On the UI,
No, on the actual video stream.
each video stream is separate. So if I were to show a large video and then thumbnails of multiple other videos, each one of those is coming down the pipe as a separate UDP stream. And then on the UI, I have a media stream object in JavaScript that I can render to an HTML video element that's layered on the DOM. Does that make sense? Does that answer your question?
No, I was thinking, you're seeing stuff that company video does.
Yes, video is an MCU, so they multiplex the video on the server side. Video is actually what powers Hangouts. So when the video goes when the video streams go to Video, the company, the service,
Yeah.
it takes all the streams and it multiplexes them. So it renders them in some sort of process that overlaps them and layers them and creates a presentation layer.
Them and you
Yeah.
can lose some of the layers.
Yeah,
You must always have the basic layer.
exactly.
And then if you got congestion, it only send you the basic layer.
Exactly. And then they render that, or they send that down as a combined stream.
Do you have to have a network that is supported by them?
It is a different architecture.
Yeah.
Because you're not doing the same signaling for that. And you would really only get one stream up and one stream down. So in some ways it's much better for the clients. But it has its own challenges and is costly to run. That's the primary.
And it also has some inherent latency to take those streams and multiplex them into a single stream and send them back out, right? That all takes time to recombine all those streams and push them back out as a single stream.
Yeah.
That's the standard.
What's that?
I don't believe it's
H.264
H.264 is a codec.
yeah, H.264 is the codec that
and SVC.
yes, SVC is how they do that, how they send
That's
out
what video use.
right. So what this would be using is in Chrome, it's going to use VP8 because Chrome does not yet support H.264.
They're talking about doing V9.
They're going to add H.264 as well as VP9 and H.265 or HEVC.
Yeah.
So those additional codecs are going to be supported too. And in place of SVC, you have simulcast, which did you talk about that?
Yeah, I talked about something.
Yeah, so simulcast fills the role that SVC does, where SVC is scalable video coding that allows you to adjust it in band. And what simulcast does, is instead of adjusting that in band, you're sending
Send
multiples,
them
and you choose which one you want to relay to the other participants. Yeah, so it does tackle the same problems just in some different ways. And what it does is kind of lets us balance the scaling between the server and the clients, saying we are going to tell the clients you have to receive more streams. I'm sorry, but we can give you streams that are better optimized for you, and we can give you fewer. We don't have to give you all of them, and you only have to send us one. You don't have to send us 5 or 10 or 20, however many people are in the conference. Any more questions? Rainey, I promise we'll fill you in. We're gonna have plenty of time. All right.
Yeah, so just some mention on costs. When you deploy to EC2, you're always going to pay for bandwidth. That's going to be the most expensive thing. We use C3XL instance. It is network optimized, it has their enhanced networking. That's where you're always going to be IO bound. Using last in and simulcast, you can reduce that quite a bit. And of course, this adds some complexity to your infrastructure, right? I mean, you're taking some of the complexity off of the client and pushing it into your middleware. So you're managing some of that complexity in the video bridge. It requires you to have a deployment stack. You have to have an auto scale strategy. You have to have a failure strategy. You have to have a backup strategy. It adds a lot of complexity, but you get a lot for it. So some of the failure cases that we're trying to deal with right now, we're still experimenting with these, is, what happens when a bridge goes away? How do we handle that? How do we auto recover the conference, reestablish the streams, and move on? What happens if we lose connectivity between our XMPP server and our video bridges for whatever reason? Somebody changes a security group, a VPC rule, whatever. Dealing with that. What happens if the XMPP server goes down? So because of the way this works, the XMPP server, the focus controller, is only in there for the initial signaling and for the termination signaling. During the middle of the conference, it kind of steps out of the way, and then once the media paths are established with the video bridge, it doesn't have any role to play except for if there's a network hiccup and the network is reconfigured and it needs to send some stream renegotiations, that's what it's for. So if the XMPP service goes down, you could technically still have your conference going. You may not be able to join any new people to it. You cannot recover from network blips, but you could still have your media streaming through the video bridge at that. So CPU, we've already talked about that. It's pretty low. Bandwidth is, of course, high going down. It's a little bit lower coming up because you have reduced streams.
The point on that one, on this slide, is that the bridge does report its statistics. So you can, over REST endpoint, determine does it report those?
It reports bandwidth, or how much bandwidth you're using, what's your bit rate.
But we can still do scaling on it. We can spin up additional bridges.
That's what we're
based on those things.
That's what our scaling strategy is going to be. Once we establish a baseline of 10 users at HD, full HD, what is the bandwidth utilization? We'll know when we're getting close to it. We can start to part of the statistics that the video bridge reports. It will report packet loss. So when you start to get a percentage of packet loss, you could start to scale up. Say you're having network issues, you're started to exhaust your resources, or you're at your max conferences, right, or max number of participants. So we're going to use that for scaling for now. Mega conferences and broadcasting. So because of the way the bridge is written, it is possible, we have not done it yet, but it is possible to take bridges and bridge them together so that one bridge could join another bridge's conference, and the maximum number that that bridge can handle can now see all the conferences from the other, or all the streams from the other bridge. That could be a way to scale this out horizontally, right? To say, we're just going to keep adding people and people and people to conferences until we run out of bridges, whenever we run out of bridges. So that's the idea with that. That is still theoretical, could probably work. I think it would be really cool. We haven't done it yet, so we'll get there. But Xander, let's talk about codecs.
So some of the other challenges we've had, I mentioned, we talked about codecs a little bit. One of the challenges is that is licensing of codecs, because H.264 is expensive and difficult to work with. So we'll definitely be talking to our legal teams and stuff about what it would take to get that, and what if we could do the costing, or if we need to actually license it, or because we're just relaying media, if we actually are on the hook for that. I'm not the one to ask about that. So
We have a legal team.
yeah, we have a legal team for that, unfortunately. Unified versus Plan B. This is an interesting one. These refer to two different ways that M lines are organized in SDP, which is the most inane problem in WebRTC right now. I hate that this is a problem, and everybody that has dealt with this hates that this is a problem. SDP is really kind of more flexible than people realize. And there were two different plans for how to organize M lines in the SDP. One was known as Unified, and one was known as Plan B. Plan B was adopted because WebRTC using SDP is more flexible with adding and removing streams, especially in the case of Jitsi, where you've got a single connection and you want to dynamically say, hey, I want to add another stream because somebody else just joined. Hey, I want to add another stream. Somebody just joined. Somebody dropped off. Let me remove a stream. Unified is much more difficult to do that with because it's stateful and the organization is very, very specific. So if Chris joins and I have an M line for him and then Chris leaves, I have to leave an empty M line for him in that place that it was in the very first message all the time. And it's troublesome, difficult to do. So Firefox supports the unified plan. Chrome supports Plan B. Microsoft Edge does neither because it uses ORTC, so it doesn't use SDP at all. So another hat in the ring. Data channels are also interesting because data channels are encrypted end-to-end. So they actually involve exchanging of keys between clients. So you can't actually do end-to-end encryption through a relay server for data channels. You could, in theory, just relay messages sent across them and open them. That would be totally fine with the knowledge that it's not end-to-end encrypted. You can't pretend that it is. But Jitsi does utilize the data channel for some useful things. It uses that for signaling things like dominant speaker and last end. So if I'm talking right now, I'm the dominant speaker, Chris pipes up, it's going to send me over the data channel. Hey, Chris is now the dominant speaker. Make sure you're showing his video, things like that. Any questions about any of that?
So you're saying that there are problems in trying to get end-to-end encryption?
Yeah, it's really just that you can't have it because you don't have a connection end to end.
No.
I don't have a connection to you; it's to my bridge. So
Yeah.
I can have an encrypted line from me to the bridge,
Yeah.
but it's not fully encrypted from me to you because we don't exchange keys. We exchange keys with the bridge.
Yeah, but the bridge is right in the middle.
This type of scenario, where you've got multiple conferences, what happens when you go one-to-one?
No, but you want multiple conferences and want it to be secure.
What the application is going to see is going to be.
Well, is somebody looking at content encryption rather than packet encryption?
Oh, you could totally do that. Absolutely, you could do that.
You can do end-to-end with content encryption, right?
You could also, if you wanted to, choose to spin up separate peer connections for your data channel that are peer-to-peer. Have your media going through the SFU, but have your data channels going peer-to-peer. That's much less fragile. You still have to maintain a lot of connections, and it's a lot of state stuff to maintain on the UI side or on the client side, whatever it may be. But that is something that you could do to solve that problem.
And you still have to deal with ICE that way as well.
Yeah.
Because you could have ICE failures on your data channel where, because the bridge is publicly available, are publicly routable.
Right, you'd have to have turn for that too.
I'm still trying to figure out where, because I was just reading about Stun and it is still not symmetric natting.
Secure to the
Doesn't solve the symmetric natting problem. You have to go
So,
through it.
somebody writes
Exactly.
a code.
So there is still a problem on, for those of us who are IoT guys, more data guys,
Mhm.
less video guys, there's still a problem of how to do natted peer-to-peer finance established sessions.
Right, and that's what turn is for.
Yeah, turn would do that, and through turn, it would actually exchange the keys end to end still, and it would relay those packets, and it would be end to end encrypted. Yeah, which is nice, but yeah, you gotta have that service. Any more questions on that? Okay. So let me go down to here. This is what a connection looks like, basically, with this architecture. This is another way to look at what Dave showed earlier. So we've got a client up here. It has for us, it's a secure WebSocket connected to the XMPP server, so your Jabber service. It's exchanging XMPP messages. Once it decides that you want to join video, you want to start a conference, it starts doing ICE, so it hits your stun server and your turn server, and the XMPP service hits Jitsi as an XMPP component. So this is a secure socket exchanging XMPP. In this case, Colibri. This one would be Jingle. And once it exchanges all the session descriptions and all of that, it can open a DTLS SRTP streams for data channels or media. And so what that looks like with a lot of, as it's building, this is it starts out there. You've just got your connection to chat. Then you add a request to start video. Everybody starts doing ICE. ICE is really fast. You're essentially just pinging servers to say, what are my candidates? What are my candidates? With candidates being IP addresses and ports. And then as that happens, you're exchanging your session description protocol over Jingle. So that's what media types do I support? What codecs do I support? What are my ICE candidates? What are your ICE candidates? You're doing all of that in band. And then once all of that works and you establish your peer connection, you get the red lines, which are your UDP and TCP or DTLS and SRTP. Any questions there? It's just kind of another way to look at what we were looking at. Cool. So
there's no simple way of making sure it's secure.
So the security is through a couple ways, right? So you would still have SRTP to the SFU. So you've still got your encrypted media, which is relayed straight through, because that doesn't require exchanging of keys. Your DTLS, yeah. At this point, my point of view on it is if you've got a data channel open, you don't have a data channel with your peers. You have a data channel with the server. So you have to rely on the security of the server. And for us, that means it's behind. It's publicly accessible.
It's publicly accessible, but it's deployed in the VPC.
But it's deployed in the VPC, right? Which is the virtual private cloud. I know things about AWS.
Yes. Acronyms.
That's not my point of expertise. That's Dave.
So, and something to keep in mind is like your initial port stuff. The port range that you have open for this is 10 to 20,000. So there's a lot of ports that are open to your video bridge because those are going to be your media ports. It always forwards to 10 to 20,000. So it's not like this thing is sitting behind there and there's only one port open. You have to have a lot of ports open in order for this to work. It's something to keep in mind when you start thinking about security.
Right.
Yeah, I was thinking of traditional security end-to-end and exchange keys both ends.
Right.
And nobody can get in the middle.
Right.
Right.
Except that you
Bridge is now
explicitly put someone
Bridge is
in the
now in the middle.
Exactly. Yep.
I mean, if you're doing peer-to-peer, of course you can do that, but you have to deal with.
I think WebRTC security in general probably merits its own talk. It's very complex. I'm not an expert in that realm in any sense. I'm not really an expert here. I'm just trying to share what I do know. But
the NSA is going to sit in the bridge.
yeah, well, and once
because that's why you record everything.
And to be honest, once we have SIP trunking and we have the ability for someone to dial out from one of these and they're able to dial to 911, we will have to comply with law enforcement. We'll have to have the, telephony world is super complex and I have barely scratched the first surface in that. But we have some experts in-house that are doing that on our service called Pure Voice that's doing all of the major outgoing telephony systems.
Well, in voice, you're going to maintain a recording point.
Yeah.
And the recording point is the bridge.
Right.
And it has to be recorded for 30 days, whatever.
Yeah. Any questions? If not, we can talk about, if you're interested in seeing some of the lower level stuff, what's actually going on with WebRTC specifically, instead of just the high level, these are the connections. I can talk about that. So you tell me what you're interested in. This is time. I appreciate you all coming out here to this, so please let me know.
I'm interested in extending this whole stuff to healthcare.
Yeah, Oh, I am too. I mean, that's a
My logic is that
billion-dollar industry, right? So
18% of GDP.
He says 18, I'd say 17.1
All right.
GDP.
And its defense budget is only 4%.
Yeah.
So we're spending all this money.
yeah, our company offers, not through us, through an external service, the ability to call your doctor over a video call. I want us to be that platform too.
That's what I'm interested in.
Yeah, it's
compliant though, that end-to-end encryption.
yeah. So the HIPAA compliance would be it is end-to-end encryption, would require that. The only thing we're not end-to-end encrypted is the data channel itself because it goes to our service. But because of that, we are end-to-end encrypted from the client to our server that we control. So in that sense, we are still HIPAA compliant, even with the middleman for the data channel.
Is there anybody else in on that? Like, for example, they said Skype is not HIPAA compliant because it goes through a second party.
Correct. Because Skype uses second parties. We're not leveraging Twilio, for example. We could have chosen to leverage Twilio to establish our calls or do our turn, or we could have used Exercys to be our turn server. But because we have our own turn server inside our VPC and we have our own SFU inside our VPC, we are end-to-end encrypted from the client to our services that we control. And we are also HIPAA compliant on our logging and our statistics.
But isn't that a severe limitation to grow the service? Because somebody else could be using Twitter.
Mhm.
Yeah.
Well-
not everybody is going to have the expertise to set something up.
Right. Well, but then
This is
if
a service,
if you
so
don't-
we wouldn't expect the client to set this up. They
Yeah.
pay for the service.
yeah, our clients don't set
I'm
this up.
just
Yeah.
saying there's another service somewhere else.
Well, that's the problem with HIPAA compliancy
Yeah.
is that it's
We only
also
did
really
our own
tough.
HIPAA,
Right.
like, one way.
And we're
Sorry.
having
It's just
to charge
also really
consultant
tough.
fees.
It's a lot of work to make sure.
It is, it's very cumbersome, all the rules and the regs, and it makes me think twice about going into this whole venture, but.
Yeah, HIPAA compliancy should make you think twice about everything that you do. And I think everyone here at this company has gone through the training and we've gone through the tech talks and I guess not tech talks, but the presentations on HIPAA compliancy. We've talked to the lawyers and it's just, it's something that we all have to deal with. And there are times I think too, where you can offer your service in a tiered way. You can say, okay, hey, my clients do not require, if you're establishing a service like this, you can say, I have some of my clients who don't require HIPAA compliancy. We could we can do some different things for them. But the way we've done this, we don't foresee any differences for our customers who need to be HIPAA compliant and who don't need to be HIPAA compliant. We have a couple services internally at Interactive Intelligence that will operate that way, but it's not really,
But the
it doesn't apply to us.
interesting service is take your Apple TV,
Mhm.
put a video on it, and run WebRTC to it.
Okay.
Because the whole point of doing taking the web and getting the reach for doctors and nurses and all the rest of it is there are many people who are, if you like, stuck at home,
Mhm.
and you want monitoring them to very quickly being able to connect and talk to them.
Sure. So the connecting and talking really just requires people at home to have an up-to-date browser. Don't use
To say you can't do that.
My understanding is no, because the connection to, the Apple TV is, it depends on how they architect that, but it doesn't have WebRTC support now, but if they did, it would still be end-to-end encrypted from the client's device to our service.
Yeah,
And
client
and
devices,
for example, we
laptops,
do eventually want to offer this as a platform, so we could potentially give you a library to use
Yeah.
to establish a connection for this. And I am not a lawyer, but my understanding is that we would just have to sign a HIPAA agreement of some sort with you, should you require HIPAA compliancy, so that you could say, my application is HIPAA compliant, we're leveraging their service, which is also HIPAA compliant. Therefore, we are HIPAA compliant.
Okay.
Become a business partner.
Business partner agreement. Yeah, exactly. BOA. Is that right?
The lawyers that made our money.
Yes. We had one in town from Indy today. Our patent attorney is in town. So, yeah. I think the real problem is like you said, if you're leveraging services that are not. So we chose not to go to
In
Twilio.
that scenario, all these fancy devices that people run
Mhm.
around with, Apple TV is Bluetooth.
Mhm.
Most of these are not Bluetooth.
Mhm.
One could take regular data.
Mhm.
But what happens to this whole infrastructure now?
It doesn't change because you have these different rules for different devices. When you have inter-device communication, it's going to be a whole different realm of. I don't even know what that entails. I'm sure Apple has done extensive legal work in determining whether they can send health data from your watch to your phone via Bluetooth. But if the phone has this connection,
As long as the phone supports SRTP.
Yeah.
As long as the phone or your watch or whatever device is connected to this service supports SRTP, then you're good to go.
Well, I know Raspberry Pi can get SRTP.
exactly. Speaking of, in January we're going to have another meetup. We're going to have one of our engineers is bringing in a Raspberry Pi. He's going to build a car and control it over WebRTC. So if you're interested in that, Mike, come along. So that should be exciting.
Yeah.
Sorry, off topic. But yeah, it's really no different. It's really no different than what you have to look at this as is it's just another protocol for HIPAA compliancy. And when you're making REST requests, so a regular old plain old website, your doctor's mychart.com, right? That's using HTTPS to communicate data from your device to the server controlled by that healthcare provider. And what that means is that they're using TLS, a secure layer, to communicate data. This is also just a secure layer. It's not any different in that sense.
Yep. And as long as we encrypt data at rest, like our recordings, then we're still compliant.
Exactly. All of our services back here have data encrypted as they pass between them too.
I wasn't aware that HIPAA was as technical as spec that it crawls into protocol.
It's actually really not. It doesn't really.
Okay.
It's really pretty vague, right? It just says everything's got to be encrypted.
Well, it's
My understanding.
basically a policy handling protocol for the healthcare industries and providers to say that privacy must be maintained.
Right.
And, aside from that saying that, it doesn't tell you how to do that or why you can't use an unencrypted data stream, over the internet.
Precisely.
But
You can use
then a
encrypted
lawyer
data
gets involved with this. Yeah.
as long as there's no identifying information in that stream. As long as you cannot type.
But if you have audio and video,
Sure, but the majority of medical data, if it's a single person involved instead of statistical data, there is gonna be identifying information, right?
Sure, that's why they require encryption.
Yeah.
And a rest.
any more questions?
There's nuanced differences between the different professions. Like I do mental health, so that's a little bit different than medical.
Sure.
As far as protections and that sort of thing, requirements, and actually our professional association has spelled quite a few things out.
Sure. Yeah, it's definitely challenging, but I think that this is a space that is absolutely going to be secure. I mean, there are already companies using it for medical communications. So security is it's still at the top of the list for all of the browser vendors and libraries that are out there. The Jitsi is up to date with its latest version. Does it use OpenSSL for its REST
If you're
endpoint for its crypto stuff?
I don't know.
Okay.
you're using IVR.
Mhm.
And you're using a phone.
Uh-huh.
You can't encrypt them over the phone.
Yeah, so we can't do IVR for some things, because if you have to enter your identification number,
Yeah.
your medical identification number, you can't use an IVR for that.
Right.
Because you cannot encrypt that.
And that's on our contact center side. Yeah, following all of those restrictions and things.
There are quite a few challenges.
Any other questions about HIPAA compliancy, encryption, security?
I'm more interested in the aspects of session initiation, you know, with done in turn and getting in and out of people's protected internet and stuff.
Yeah, so ICE is complicated, and I won't pretend to be an expert on that either. It's
It's complicated and it's not 100% reliable. You can have the
Yeah.
same connection take the same path.
and you can have a connection established through it, and then all of a sudden it changes, and you have to renegotiate and figure out where you can connect now. Because maybe that
Some
port
very
got
valuable people, though.
severed by your network administrator or something. Like, yeah, it's complex. But I think the best thing that anybody can do is leave that to the people who have done it, because all of your compatible libraries are going to support it. And don't reinvent the wheel. It's I know it sounds like, yeah, you want to do it on their hardware and do this stuff, but piggyback off of Pi and use a node library. Like, it's just, I got to reiterate that, because that's the best way to do it. Is you don't want to implement that stuff yourself. Yeah. Any other questions?
There are publicly available terms for this out there.
They're probably not.
Yeah, I can't understand that though, because who's putting the bill
Google.
for me?
Google has
routing all my packets?
Google has a couple turn servers that they have running. They don't widely advertise it, but it's mostly for developers to be able to.
Yeah.
Man, I want to build something, but I can't spin up a turn server. But that's also what Twilio and Exercys provide.
We started using Google's term server here before we deployed our own.
We use the Sun server, which is still free and public.
We use Turn
The Sun doesn't have the same problem because it's only handling
Right.
the initialization.
It's like a ping server,
Yeah, exactly.
basically. Yeah.
Doesn't route traffic.
Right. Yeah, as soon as you have packets flowing through you, now you've got an issue with whoever's cloud you're running on, right?
Yeah. Yeah. Cool. Phil, any questions?
No, I already know all this stuff.
Okay, cool. Is anybody looking at the YouTube thing? I don't know if there's been any comments or questions. I think Austin is probably the only one on. One viewer. That's got to be Austin. So he'll hear me say his name in about 15 seconds.
It's like a 30-second delay.
Is it?
That's an interesting question. What is the latency if you have your bridges going up and down and you're looking for another one? What's the latency for reestablishing your video if you temporarily lost it?
Well, that really depends on your infrastructure, because if you lose a bridge, do you have other bridges already up and running?
Let's
Or
say
do you
you
have
do.
to deploy another bridge? right?
Or, the other interesting aspect of this is, are you implementing as microservices in like containers, Docker and now?
Yes, we
Okay.
have much, all of our infrastructure is Microsoft.
So that helps you spin up in, sub 10 seconds at least, right?
Well, you're
Yeah, we don't use Docker, but we have AMIs, right?
We use JVMIs right now, but you would probably want to over provision your environment to have enough video bridges so that if you lose a single bridge, you have enough capacity across your other bridges to pull those conferences in very quickly. Because anything more than a couple of seconds is not going to be acceptable.
Like
And-
you,
and the
like you
rene-
said
the-
also, it doesn't cost you anything because it's only the network traffic. Which is really your
Well, it does cost you.
Yeah.
EC2, you're paying by the hour.
running the big instance and running the network traffic is expensive. But sorry, I lost my train of thought. Oh, right. So how long does it take to reestablish a connection, assuming you have another bridge ready? It's like a second at most, and that's because it's really quick to establish that socket and just start saying simultaneously set up a channel for this person, and they're all renegotiating their ICE and ICE happens in under a second in most cases.
Yeah, I mean, ICE can be extremely quick. There have been conferences that we've been running where a renegotiation of the stream will happen mid-conference, and all you'll see is a small flash. And the stream continues.
Yeah, and to give you an idea of how quickly it sets up, what I usually look at for a success state for the first person joining is I join here, and this browser gets a toast notification, and that happens in 10 to 15 milliseconds most of the time. So that means that first person is saying, I want a session.
Right.
It creates the session, it adds their channel, it negotiates ICE, and it sets up the connection and notifies the other person in that time.
And
It's really
in
fast.
reference to the talk on the car control, any kind of real-time performance, the loss of video might be, you know, if you're actually driving something, might be important, right?
Yes. Yeah, I'm not going to pretend to put this on any aerial vehicle and go on any critical. I'm not delivering any tacos over WebRTC right now.
Walmart is, and certainly Amazon has been looking at that for a long time.
Absolutely.
Walmart's starting to do the testing right now, so I'm sure somebody is gonna, if that's not gonna be totally autonomous, somebody's gonna be in the driver loop and wanting to see some visual feedback of where this thing is going.
Well, you can also force WebRTC over TCP. You can force your media channels.
Which is actually worse though, because
It would add a lot more latency.
Yeah.
Because you're guaranteed it's going to get there.
Forces all of them to
Right.
hold off.
Yeah.
Right.
You didn't say it'd be better.
Yeah, exactly. Yeah. So I think we're all going to rejoice when we have fiber and our WebRTC connections are lightning fast, and that's why I'm never leaving the train.
Or 5G with Verizon that beats fiber,
I
right?
mean, the limiting factor on all this real-time communication is our networks.
What thought has gone into working with other services?
We definitely want to federate with other services. We want to make our libraries open source and be a
I
platform.
mean, have you looked at Dropbox?
We will not be using other video services that provide video as a service because we are providing video as a
Somebody
service.
else would be.
Yeah.
Want to connect to the service you.
Yeah, so there's this problem here. Where'd my whiteboard marker go? Here. Does this work? Oh wait, no, it's this one.
Well, Verizon will have something. and
So,
AT&T will have something else.
so you have this problem of
Yeah, but
this
I'm
is-
just browsing.
this is in Pure Cloud, and this is over here. This is TalkBox, and this is
Verizon.
well, this is
AT&T.
Joe's iPhone app.
Yeah.
Joe's iPhone app is going to connect to one of these, but not both. So it's going to do this, or it's going to do this. It's not going to do both. So it's going to use one of us as a video platform. But there is also this nature, which is where, say over here, we've got Talkie. Talkie uses the same signaling as us. So say somebody's on Talkie's web client. So in this case, treating that as an app communicating with a service,
Right.
and somebody's on Pure Cloud UI in a box over here. These could connect like this.
Yep.
But we wouldn't connect to TalkBox because they use a different signaling.
Right.
Yeah.
So you can basically create an XMPP server connection between Talkie and NM Pure Cloud, and then they would selectively forward messages to Pure Cloud based on who the participant is,
And
what
this
the
is
address
and we could do the same way
Yes.
if we wanted to connect a Pure Cloud UI to a Talkie conference, because they have their own back here. They've got their own XMPP and Jitsi and potentially even HipChat as well.
So I'm saying that if you go into the healthcare, you've got one hospital, they've chosen Talkie.
Mhm.
Another hospital has chosen TalkBox.
They're not going to intercommunicate.
But the client, the patient is, Joe's iPhone.
Mhm.
And his nurse is on one and his specialist providers on another one.
Yeah, he's gonna have to have two apps.
Yeah.
Joe's iPhone's gonna have to have a Talkie app, and it's gonna have to have a TalkBox app. And that's the problem with not using standards. That's why
Oh,
we're
yeah,
using
yeah,
XMPP. Yeah,
There's a
it's
lot of room for establishing new standards
That-
for this stuff.
these are silos of data, and it's terrible. It's walled gardens, and it's all awful.
It's not like they can't speak two languages. They could create a translation layer.
Sure.
Where
Yeah, but they never will realistically, because now we've got another standard,
Maybe
right?
it's not
Like,
impossible. They
well, it
could.
is nearly. It. In all reality, it is impossible,
Yeah.
because no one is going to do that, because they're different platforms, and they're going to say, if you want your hospitals to be on the same system, Duke Raleigh has got to use the same system as Duke.
You're not going to maintain
Greensboro.
20
You
integrations.
have the same problem today.
Yeah.
You try and get your health data.
Exactly. My dentist is on one website, and my doctor's on another,
That's right.
and it's because they're using different databases and different things like that. And fortunately, we have our country has gone to, at least to some extent, of using EMRs so that we can have a way to exchange those between systems. But yeah, in theory, it's possible. In reality, it's not gonna happen. It's the same reason Facebook will never open up Facebook Messenger's video chat to ever work with Google Hangouts, because why would they want to, right? Unless their goal is to have open standards of communication.
Well, there was one, I forgot the name of it. They use, like, they support IRC, they bridge IRC, XMPP, they bridge multiple standards.
Yeah, and it's much easier to do that with text than it is to do with audio video. So those kind of things you could see. Like, you can get a chat client that you can be logged in once, but logged into Hangouts and Facebook and Twitter and whatever. But exchanging these real-time streams is just nigh on impossible with having different codecs, different signaling, different infrastructures. Am I getting one stream over the same peer connection, or am I getting multiple peer connections? Is it an SFU or an MCU? It's just, it's,
You support
So,
unified or
so
Plan B?
yeah.
theoretically, this would work though because the video bridge registers itself with ICE, so it's available. Is that right? Like using, trying to detect which connection is going to. Like, earlier when you were showing the architecture, I just assumed that the signaling would come back and say, well, here's really your video bridge IP, you know? But
Yeah, that is basically what it does.
it doesn't use ICE to then determine that the video bridge is the right candidate.
It knows that it's communicating with the video bridge as a peer, and it has like a to address, so it addresses its messages to the video bridges. It sends its messages to the room JID, and the room JID, the real-time server, is smart enough to know these messages go to this conference on this video bridge. And so when the video bridge says, "Hey, I got a nice candidate for this room," it says, "Oh, let me let this person know in this room for this conference that this is the ICE candidate for the bridge." It doesn't have to do any guessing or anything about which bridge to use. The client doesn't. Real time, the signaling server, will do smart detection of, what's the best bridge to spin up a conference on.
Right.
Yeah.
That's what I originally assumed that there was a statement about ICE. You're showing earlier, you're showing the multi-network lines doing all the clients initiating all the ICE and turn stun and everything.
Yeah.
And being told.
That is mostly for the bridge to know what the client's IP address is.
So they can establish.
So by
the-
when you hit stun, you're determining what your IP address is. What's it look like my public IP is? And I get that back, and then I send it to the person I'm trying to connect to.
That's right. It's still considered your So,
Right,
so
exactly.
it's not the client server where.
Yep.
You know,
Yeah.
and we'll have another-
Bridge is still up here.
Yeah, so it still needs to.
It's just a
still
much
adding
quicker
markers.
Yeah.
So the question.
Yeah.
There's always a bridge involved. I mean, see some kind of involved with you. But if there's two clients, they can't use a protocol like the ICE to figure out where they are in their peer-to-peer.
Yes. So right now, what we are doing is, if you're in a direct one-to-one chat, you will actually connect peer-to-peer, not using the bridge. And
Or turn servers, because we have
But
turn
you've got to
servers.
find out where they are.
right,
Yeah,
so
we
you
have
use
a-
ICE
we
for
have-
that.
We have a turn server that we have deployed, and we can use stun. They try with stun first. If that fails, and they try with turn, and then they connect here.
Yep.
We have a publicly available turn server that our clients use.
And someone else. Yeah. And there's
you can
also
secure your turns as well. So it takes a turn secret in order to use that turn server. So it's not just sitting there taking turn requests from everybody.
yeah, there are also some strategies you can use in groups. So say
Or gender
Uh,
studies.
So say the group of us is in a XMPP chat room, but only you and I join video. In theory, we could do a peer-to-peer communication, and then once a third person joins, then we disconnect and we switch over to using the bridge.
And obviously, is a small bit.
Right now we're not doing that quite yet because we want the lightning fast, like everybody joins video at 9 p.m. or 9 a.m. for stand up, and we want everybody to join really quickly. We don't want to have that blip between the second and third person. But we will probably adjust that.
The other way, if you want to join in the US, just copy that.
Well, so what we do is we differentiate between group chat rooms versus a direct message. That's our distinguishment right now. And eventually we will change that. Yeah. Any more questions? We got plenty of time. Feel free to leave if anybody wants to leave. Stick around if you want to chat.
So,
Ask more questions.
I was, my curiosity was piqued when you were talking about extending bridges. And it's kind of an interesting question of the conversation, like UDP is a very nice sessionless. So you could drop packets. You could, in theory, make a hybrid where instead of your routing everything through your central server, you did some combination of peer traffic for a larger network, right? Where you're sort of raining down packets. I don't know how the protocol would go, but I'm just putting it in my mind. You can imagine instead of everything trafficking through the central server to provide this, what you call it, the multiple worlds concept, where you get disconnect in a bridge and you've lost traffic. The internet is resilient itself, right? So if things didn't have to pass through a turn server to get end-to-end encryption, you'd have the problem solved, right?
No, you wouldn't, because the internet changes topologies all the time. So even if you're peer-to-peer, you're going to constantly renegotiate to adjust the network blips to different routing changes. It's not like you establish.
So traffic itself would bottleneck and somebody would shut something down, and then you'd have to find a different path for your packets.
That's what WebRTC does. It will renegotiate, it will regather ICE.
Okay, so this is really quality service on top of the raw internet. I visualized it as, UDP is just flowing and pick whatever path it leads to through the internet. But you need to maintain some cadence of packet transmit in order to get the video.
Right. So WebRTC as a kind of a package deal is it's a set of APIs for the browser, and it's a standard. Well, it's really a standard of APIs in general. So you could use it in Node, you could use it in an iOS app or a Java app, Android, whatever. So it's a set of APIs. It's a standard of protocols. So it's saying use these protocols for this and use these protocols for that, and that includes ICE, which is the negotiation for it. ICE is a protocol itself. So ICE really means as I need to gather candidates for me to transmit media, basically. So that's a part of the protocol is saying I need to do an ICE renegotiation because the network changed. Does that make sense? So it's really not. It's not really just low-level UDP.
I mean, for instance, if I am getting cached data from someplace across the world, right? Like we go to Akamai out in China, and we're picking up some cache for a web page that's displayed. It just hits that latency, and those packets come in when they do. So I'm trying to think of what you talk about the star network, and you say, things are going to get detached, and I'm going, well, it's the internet, right? Where these 5 points on the star are, do they have to be geographically central? I don't think so, right?
Right.
Okay, so I could be in China, somebody could be in Israel, somebody could be here in the United States, somebody up in Russia and what have you. And now those points need to get together with some routing over the real internet too, right?
Right. The problem is not that it's that everyone is connected in a star topology. The star topologies themselves, it's effectively a fully connected distributed system. And fully connected distributed systems are overall good. But it fails for real time. That's where it's
Fails
failing.
for
us.
real time.
So when you have that media thing and you need, in order to have any kind of integrity of the system, you have to have, because that's the benefit of a fully connected system, is that you can cut one of those connections and it fails, but everyone else is still fairly resilient. But when you have a real-time communication channel, if one of those fails, you've now compromised the integrity of the entire thing.
Have you looked at your system and how it works if somebody is in, let's say, Japan?
Yeah, we have.
Some other 4 people.
I had a guy on a video conference on an airplane.
Okay.
I had a guy. We have people in Europe. I'm sure Don was on a call when he was in China at some point. Yeah, it's not the fact that it's geographically located or anything like that. It's really the real problem is that because it's real time data and everyone is relying on everyone as opposed to everyone being able to get to everyone, then the integrity of it fails when one of those nodes fails. And then also you have the scaling problems of I can't upload 100 streams. I can't download 100 streams. I can't render 100 streams. Yeah.
Is video mandatory on your tools?
No. Right now, if you have a webcam, it will turn on, but you can mute it.
Yep.
We're working on being able to completely turn off your webcam.
So as an organization, within your organization, when you have 3 people,
Mhm.
as a percentage, how many people mute their video?
Right now, it's fairly high because of the bandwidth problem.
Oh, really?
That's the major concern that people have. There are people who mute just because they don't like to be on camera or whatever, or people who mute when they're not really talking. We don't have good statistics on that yet. That's one of the things we're about to measure. But I would say the overwhelming majority of people who mute their video is because they want to reduce the bandwidth and CPU load on the call as a whole.
Oh, really? That's nice because I would see the girls would not want to go on. They didn't have a hat on their head or something like that. They didn't have makeup.
Well, once we start enforcing last in as well, then you will only have the last 2 dominant streams, and everybody else will be.
There's a great chapter in the book Infinite Jest about the dystopian future of video teleconferencing. I highly recommend you read it.
Cisco, you have it, you have expensive equipment, and you see the
Nope.
girls would mute their video. What do you want to do?
Hitchhiker's Guide called ESP, a social disease for point culture.
Yeah.
Where everybody could read each other's minds.
Yeah. Thanks for coming. Have a good one.
The biggest thing for us is we're a telephony company, and yet everyone uses our WebRTC audio over their
Yeah,
phone.
nobody uses their phones.
Yeah, it's kind of funny.
So,
Audios.
4 is turkey,
Videos.
6 is veggie,
Yeah.
and 1 I think is ham or roast beef.
5 was
Uh,
one
was
one
ham.
is ham. Yeah.
1 is ham.
5 was
ham, yeah.
pastrami, right?
Okay.
So somebody just won a FCC approval, one of the major carriers, and it took me back. They're routing phone calls now over the internet again.
Yeah.
And previously, like 10 years ago, one of the major carriers, I think it was Sprint, was running their phone calls, mobile phone calls over AT&T's wired networks.
Yep.
And AT&T sued it, and that's when that stopped. And I
Yep.
think it's coming back right now. Everybody's got enough network.
Well, everybody's doing it anyway. Everybody's using FaceTime or FaceTime audio. You're not using your phone calls. That's why voice networks.
Everybody has forced them to change because nobody is using a traditional mobile call anymore.
Yeah, it's all going to data. Data is data. Bytes are bytes, and nobody cares about phone calls. Yeah. Yeah. So
It's the way of the world.
Things changed. It's called BOLD, about disruption. Basically, constant disruption is what we're going through now.
thanks, Garrett. Have a good one.
You try to build a business and you're lucky to get the business off the ground before somebody comes with a new technology and disrupts it.
Yep. Cool.
This seems to be taking a while though. been around for a long time.
It is, and yeah, but how long was the internet around before it took off? I don't know. There's yeah, it's difficult, but there are I think very unique challenges with this, and it was really a while before Flash even was able to do video kind of reliably in any sort of way.
Years and years
Wasn't
ago,
great.
you know, you had click this button on your web page, and our ISDN phone will ring you back. So it'll help give you some advice on your purchase.
Mhm.
You've got the ability now to click an icon on a phone, on a web page, and you can have an audio call with someone at Amazon or whoever.
Yep.
To discuss the product purchase or whatever.
Yep.
We're not seeing it yet, and it's free.
Yep.
It's free. I don't get it.
Well, I mean that's SIP soft phones. I think the signaling and the protocols.
WebRTC is free. It's there. It's built in.
Yeah, well, what I'm saying is SIP soft phone. So you can use SIP over WebSockets to make a WebRTC phone call. So where your browser to your PBX actually looks like a phone.
Sure.
That's something that we're doing. I think it's been a lot, and I think the problem has been it's that a lot of technologies took a while to work together. And that's what WebRTC is, and I think that's why it's taken so long. It's not really a new technology. It's an organization of a whole bunch of different technologies. And then on top of that, they left out signaling. So you have to figure out signaling yourself too, and everyone's done different signaling. So so that has been really challenging. But because now there are standards evolving, we've got like all three major browser vendors behind it. Major companies all over the world are supporting it or developing with it or whatever. It's in, yeah, I think it's the expansion bubble has started. It's gonna go up, and it's gonna be very rapid very soon. I think there's no denying that when you've got major telecoms and major internet providers and major software vendors, yeah. I mean, yesterday was WebRTC Conf in Japan. It was a conference all about WebRTC in Japan. Japan's a small country, so
You can see the potentials.
there are startups around just testing WebRTC. There are startups just around collecting statistics. There are multiple platforms out there for eliminating the need to do your own signaling, eliminating the need for your own turn server. Yeah.
Now with meetups, it's going to become convenient. There's a bio-curious meetup over in San Francisco that I'd like to attend, and I've pinged them several times and said, hey, is anybody recording your meetups, because they've got a lot of cool tech talks and
Yeah.
biotech, and nobody's doing that, partially because there's still a thing about setting up the technology.
Yeah.
Even though there's GoPro cameras, there's basically the recording equipment is built into everybody's laptop or smartphone.
Yeah, exactly. I can't tell you the number of times I've been at a tech conference and somebody says, hey, come to our tech talks at such and such company. And I'm like, oh, cool, but I live in North Carolina.
Yeah,
Are they online? No. I'm like, why are you a software company then? What are you doing? Like, I know you don't make the video chat, but you can't figure out how to use Hangouts on
You
air.
didn't actually ask them that, did you?
I did.
Oh,
I said, what do you do? I said, why not? And he couldn't give me a reason. And I said, because you haven't tried.
Good. I'm glad you gave him help, because
Yeah.
you'd like to argue with some people who say you can't do it, but you also aren't there, and you don't. Right now, there isn't a lot of technical comfort with, okay, I have a video stream I have to set
Yes,
up
and I
project.
totally understand for non-technical meetups, it's a challenge too, because they might not even bring a computer to the meetup, right? It might be a knitting circle.
Yeah, but
Well-
most of the meetups I'm going to are computer meetups.
So look at me when you say
Yeah.
that.
No, I was thinking my wife. My wife knits. I'm looking around the room at everybody. My wife would like to join a knitting circle that goes on in Kent that she used to be a part of in Ohio, and she can't join it because they don't have a camera there.
Well, you're on the cutting edge of virtual practice, where we're getting there, where the geography doesn't matter, and I can be out on the West Coast.
Yeah.
There's a lot of IoT stuff going on the West
Yeah.
Coast. I'd love to be there. But
I saw something particularly ironic on the internet a couple weeks ago. It said urgent WebRTC contract in Seattle.
Must work here.
Yeah, remote not acceptable. I'm like, what? That's ironic. Yeah.
My friends got married at Toilet Bridge Pub several years ago, and the mother is disabled and requires a lot of care, so she stayed in Oklahoma. But I was there with the laptop, like, just lifting it up so that she could see with all the activity, and was able to somewhat attend her son's wedding.
As soon as you said wedding, I just realized there's a new market.
Yeah.
Now you get your
Oh, and
flowers,
And funerals.
you get your flowers, you get your decorations, you get your stream. So for all the people who RSVP, no, why can't they sit there and watch your wedding ceremony? Who's got some free time next weekend?
Really, because that is big business.
I'm serious. Chris, Dave, did you hear that?
Yeah.
We should do that. Set up a business to go live stream weddings in Raleigh, Durham, Chapel Hill.
We could blow it up, man.
Holy shit, we could make a lot of money on that.
People go to the weddings for the bar,
Well, hang on.
not to see the ceremony.
But there's grandparents out of town and stuff like that that would want to watch. And births, if we could live stream a birth,
Oh,
Dave-
no.
Yeah.
I guarantee people would want to see that. And it doesn't have to be the birth itself, but if you're in the room, people would want it. I guarantee it.
Just to see the look on his face.
We'll even provide you the hardware. Here's the tablet. Set it on the tripod. Have a nice day.
Dude, you guys want to start this? I'm serious. We could make money off
I've
of
got a
this.
GoPro. GoPro integrates with Wi-Fi.
Oh, yeah.
Wait, I get a
By the way,
credit.
you
That
throw
was
the
my
hardware.
idea.
Keep coming to the meetup.
Here's the tablet, you don't have to mail it back.
We can build a prototype tonight. I have my GoPro on the
Phil,
So Xander,
early investor?
Xander,
I'm not kidding. What?
funeral, he attended a webcast for a funeral.
There was one?
Yeah, right here, his website it's not service, it's just what the shop
Weddings
does.
are kind of like funerals. People are always
Could be.
crying.
See the website?
Yeah.
I wanna see this.
They died. They died, then it's a webcast of it.
Yeah.
Yeah, but, you know, typically for Friday, November the, what's that? The 6th. So last Friday, we had one.
This whole site's dedicated. The company does
No, it's a funeral
No,
site.
it's just a funeral
And they just do
company
webcasts
in
with other
Melbourne.
services.
And they can webcast the funeral. So like you have to be in Melbourne.
But if there was, you provided us a service where you go to these events. you set
That's a
up
great service.
Yeah.
All they need to have is a.
Yeah, especially when you have two on opposite ends of the coast,
Well,
because,
this is my uncle. I couldn't go to Australia.
well, my uncle, Arizona and Chicago, there were two of them. Because that's where he grew up in Chicago, but then ended up in Arizona, and then some of the older brothers and sisters couldn't afford to go back. And so it was kind of, it sucked.
Yeah.
Yeah.
Paid a guy to take photos.
But,
I had on his chest.
Yeah. I don't know how much business you get around here though,
Well,
for that. I mean, for videos in general, to film it, yes.
Yeah.
People are dying to get into facilities, so,
Just filming in general.
Yeah, videographers, but
I like it.
but I think if there's something to that live stream that people would pay for.
there should be some.
Like video cameras have Wi-Fi.
Oh,
I'll
it's
say
to
they
tune in?
But I think it's a great service for the family.
Well, I think the wedding is specifically a